Saxon Algebra 2, Lesson 100, yay! We made it to the triple digits. This is a very exciting day. So take a minute, pat yourself on the back for surviving 100 lessons of Algebra 2. It's no small feat. And that puts us all the way at the end of week 26. 5 more to go, and we're done for the year. Amazing, right? Let me remind you that if you look in the Saxon Algebra 2 textbook, you'll see it actually goes up through 127. We are only going to do 120 lessons. I might change the specific number, like we might skip lesson 117 and this would actually be 118, something like that. But we will only do 120 lessons no matter what their numbers are. We'll deal with that later. There are some lessons at the end of this book that are not particularly well done in my opinion, and we will skip over those. So no matter what their numbers, we will be done at 120, and that's very exciting. This is a challenging book, and you're doing a great job if you're surviving to this point. All right, we are going to graph parabolas today. We're going to come back to this next year and do it some more, but we're going to get a chance to kind of warm up this year and get it into our brains. It's kind of a lot, so buckle in, and you know, if you can just hang on and follow what I'm doing, it'll come to you. It's a number of steps. So anyway, now that I've psyched you out completely, let me remind you of what kind of equation will allow us to graph a parabola. This we've seen before. This is the standard form of a quadratic equation, right? The highest variable has an x squared term. So this is nothing more than our old friend that we've seen quite a lot of this year. And when we graph it, we will get a parabola shape. And we've looked at that before. We've looked at the shapes of quadratic equations, cubic equations, absolute value equations, and square root equations, right? Remember those pictures we've seen? And a parabola is that U shape. The very simplest one looks like this, right? It's symmetrical, side to side. It's expanding as it goes out. You'll notice that it passes our vertical line test for a function. It can also go up and downward. And we'll get into more of the details of this, but generally speaking, if it's positive, if there's a negative in front of it, it'll open down. But we'll get into that more later. But this is the basic shape. We are not going to do anything side to side or tilted. They'll all be quite balanced and relatively straightforward. So that's what we're doing. Let's dive in and start on an example. John does like 4 pages of preamble. I'd rather just explain as we go. Example 100.1, that looks nice, doesn't it? All right, so the equation that we're given is y equals x squared minus 4x plus 2. And John says something that's somewhat chilling. He says, complete the square to graph. What? Yes, it's true. In order to get this into the form we want it to be, in order to graph it easily, we need to, quote unquote, complete the square. Remember when we did that back in the day? Before we learned about the quadratic equation, the man-eating dragon? Yeah, we're going to do that here. So I'll remind you of all the steps because I know that's not one that everyone remembers. So over here, I'm going to write steps to complete the square. And so we'll have some words over here on the left, and then we'll actually do the numbers. Now, way back when I first taught you how to complete the square, I told you that we would move this last number, this C, if you will, we would move it, before we were moving it to the other side of the equal sign. But I used a different expression. I told you to kick it to the curb. And the reason why you're gonna learn today. Here we have a Y on this side. We can't move this 2 to the other side of the equal sign because our equal sign is busy holding on to the Y. When we did completing the square before, we didn't have that. So we can't move this 2 to the other side of the equal sign. So we have to kick it to the curb in a different way. So that's our number 1 step, is to kick C to the curb. And the way that we do that is with parentheses. See what I did? I just scooched him over and put these guys in a little parenthesis club. So we use parentheses to kick 2 to the curb. It's different, but it's still the curb. You know what I'm saying? It's still the curb. Now, what we need to do is calculate our magic number. And good news is that's exactly the same as last time. I'm going to use the hashtag symbol. It used to stand for number. We're going to bring it back. All right, and the way that we do that is we take whatever our B value is, we can think of it as dividing it by 2 or multiplying it by 1/2. Same. And then we square it. That's our formula, okay? We also draw an arrow to this because the number inside the parentheses is important to us. In our example, our B value is -4/2, again with the arrow, squaring it. -4/2, okay, that cancels and it just becomes -2. -2 squared equals +4, right? The magic number will always be positive, but sometimes this number is negative, right? We pay attention to that. Now what we want to do, I'm going to make my third step go over here. Add the magic number This doesn't make sense until I show you. We know we want to add the magic number here, +4, right? Now, we have to find a way to balance that, right? And the way we did it last time was this was on the other side of an equal sign, and then we could add 4 on the other side. But we're not doing it that way this time. Everything is squished together on one side of the equal sign. So we have to find a way to balance it without having an equal sign to help us. So what we do, since we added 4 here, we will subtract 4 there. That's what I mean by saying add the magic number inside, subtract it outside. The magic number will always be positive. So adding and subtracting will always work for us. All right? Okay. The next step is, this whole step is exciting and different and new, right? The way that we do that. The next step is write as a perfect square. Okay, we know that we have built a perfect square here. So we know that we should be able to rewrite this as 2 binomials. This number that we drew the arrow to is the number that goes inside the parentheses. It's -2. So we should be able to double check these numbers and make sure they work to this. They should multiply to this number. Yes, that's +4. And they should add to this number. Yes, that's -4. So that works. But we're not quite done because we have to do this. That now simplifies to a -2. Okay, beautiful. And then the last step, which I'll do at the top of the next page, is, and this, by the way, this step is exactly the same as last time, no difference. So now I'm gonna write this at the top of the next page. Okay, that's where we were. The last step in this part is we write this as a perfect square. I didn't do that on the last page, but we can do it really easily here. X minus 2 squared minus 2. Okay, we are done. We are now ready to graph. Now, in order to do that, we have to figure out how all these numbers are going to help us. So I'm going to show you now the detective clues that we use. Notice how there's nothing out in front here? We could put in a plus sign, right? This tells us that the graph opens upward. It opens up if it's positive. It opens down if this is negative. So the sign, plus or minus, in front of this tells us which way the parabola opens. Remember how I drew the picture here? With one going up and one going down, and I put the positive and negative. Oh, now you understand, right? That's the way the positive one looks. That's the way the negative one looks. This number and sign is called the axis of symmetry, and we often think of it as the x value, okay? And I'll graph this in a minute and you'll see. But what I mean by the axis of symmetry is it's the line that goes right through the middle of the parabola, like that. All right? And here's a tricky thing to remember. The actual value of the axis of symmetry is the opposite sign. So our axis of symmetry in this example is going to be positive 2. I know, right? Why must it be the way that it is? And if that isn't confusing enough, this number and this sign are what we call the vertex. It is what we call the y value, and I'll show you on this old picture. It is, see how this is the vertex? This is like the extreme point, either the bottom or the top of the curve, depending on which way it's going. The vertex is like the extreme point of the bend, okay? And that we measure up against this y-axis, all right? It'll make sense when you see it in this picture in just a minute. This has the same sign as it's going, okay? So here we say x equals -2 and y equals positive, no, I did that wrong. This y is +2. Sorry, that was, as if this isn't confusing enough. I tell you the wrong thing and make it 100 times harder. Axis of symmetry is the one that messes with your head. I remember that because, have you ever heard, back in the day when President Ronald Reagan referred to the former Soviet Union as the axis of evil, or maybe it was George Bush, I don't remember, and that the axis were the bad guys in World War II. That's what I always think of. This is the one that's more devilish. This is the one where you have to take the opposite sign. The vertex is the one that's more straightforward. He might be hanging off here at the end like a weirdo, but at least he doesn't give us problems with his sign, right? So, sorry. Okay, now we're ready to graph. So we draw ourselves a nice little picture. It doesn't have to be too big. If you think about 5 units in every direction, that'll be fine. And I'm gonna just put in some markers on the x-axis. I'll use the blue lines on the y-axis. So what we do, first we get it in our head that it's gonna open up, right? Because it's positive. If there's no negative sign, then you know it's positive. The axis of symmetry is at positive 2. X equals positive 2. So I go to x equals positive 2, and I put a dotted line. That is going to be the center of my parabola. The vertex, the point in the curve where it bends back in the other direction, is at -2. So it's on the axis of symmetry, but that tells me where to put the dot. Now I know that it's going to be going roughly like that, right? It's going to bend up. But we have one more point that we have to graph, and this is step number, well, these were my steps to completing the square. The last thing that we have to do is find one more point. All right? Finding one more point is going to help us define the shape of this curve, how wide or skinny it is. And the way that we do that what we're going to do is we're going to look at the axis and we're going to go 2 units to the right or the left. You can choose whichever number you think is going to make you happier. So in this case, we're at positive 2, right? So we can either choose 0 or we can choose positive 4, right? So I'm going to write that here. We can choose 0 or positive 4 in this case, right? In other cases, the axis of symmetry will be at a different place, so you'll go 2 units to the right or left for that one. I'm going to choose 0, and what we'll do is we'll plug that back into our friend here, and then we're going to solve it for y. So I need to go to the next page. It was y equals x minus 2 quantity squared minus 2, right? That was our equation. And I'm going to let x equals 0, right? It could be 0 or 4 in this example, but I like 0, so I'm going to say y equals 0 minus 2 squared minus 2. 0 minus 2 is minus 2. Minus 2 squared is 4. 4 minus 2 means that y equals 2. So another point that I can graph is 0, 2. Okay? So this is one more point. Continued. All right? So now I take this back to my picture and go, okay, I know that 0, 2 is another point. In my parabola, right? Now, here's the thing. Because our parabola is perfectly symmetrical, that means that if I go 2 units to the right, there will be another point right there. So even though I just calculated one more point, I get to add 2 to my picture because I just put one directly across from where the other one is, right? I go 2 units, and it's at positive 2, so it's at positive 2. Now I can draw the picture. And that is the picture of the parabola y equals quantity x minus 2 squared minus 2. That's it. And I'm going to write that right here. Y equals quantity x minus 2 squared minus 2. That's the name of this parabola. It's the graph of a quadratic equation. What? Did you feel smart? I want to label a couple things on here. The axis of symmetry, and of course I want you to label them too. The axis of symmetry is the dotted line. I make it dotty because it's not actually part of the shape of the parabola, but it's the line of symmetry, obviously. It's the dividing place that we get the perfect halves across. So it helps to visualize it. This point down here is the vertex. It's the bend in the parabola. It's where it changes from going down to going back up, if you want to think of it that way. Okay? Wow, that was a lot, wasn't it? That was a lot. We're going to do it 2 more times. You can do it. Ready? Okay, example 100.2. Here we go. Y equals minus x squared plus 2x plus 2. Now, we're going to do something different this time because look, ew, minus x. I don't like that minus in front of the x squared. So what we're going to do, oh, it's tricky. What we're going to do, first we'll factor it out of not, yes, all 3. We're going to factor it out, and then we'll have x squared minus 2x minus 2, right? I pulled a minus sign out of all of them. We're going to toss that minus sign over to the y. The way that we'll do that is to multiply or divide by minus 1, however you want to think of it. These cancel, and now well, I kicked him to the curb at the same time. That might have confused you. But do you see how basically what we've done is we've stripped the minus sign out of this side, and we've tossed it across the equal sign, and now the y is going to hold on to that minus sign for us while we do all our drama over here. And then at the very end, we'll put it back. Isn't that a clever little puzzle? Okay, so that's what we're doing. I just have a very visual image of we're playing like hot potato, and y is going to hold the minus sign for us while we do our thing with the other side, and then y will toss it back. So now we're dealing with this without the minus sign, and I kicked the minus 2 to the curb right away. That might have confused you. I just did 2 steps in 1. I'm sorry, my brain was going too fast. All right. Now we need our magic number. The magic number is the b number, minus 2, divided by 2, squared. We draw an arrow, right? This simplifies to minus 1. Minus 1 squared is positive 1. So we add 1 there, but then we have to subtract 1 to balance, right? Plus 1 minus 1. That works out beautifully, doesn't it? All right. Now we're ready to write this as a perfect square. So we're leaving that minus over there with the y. This then will become x, and we can use this right there. We know the number inside the parenthesis goes here. I'm going to skip writing the 2 binomials side by side and then collapsing them. I'm going to go straight to collapsing. This then becomes minus 3. Right? Okay, this looks really good. That's how we want it to look, right? Now the only problem is we have to bring the minus sign back. So, again, you can do it by multiplying or dividing. Whichever makes more sense to you. I'm going to do it with division this time. This cancels. We have our positive y back. Now what happens here is that we have to make this quantity turn negative. Oh, this should be, oh no, that's right, x minus 1 squared. This minus sign is going out in front. There it is right there. That's how it handles this term. Over here, it'll change the sign in front of the 3. So now our equation is positive here. There's a negative sign lurking out in front. Oh, now we know how that happens, right? And then the rest of this looks more or less like what we did last time. So we flipped the minus sign over to the y. Y held it while we completed the square, and then we passed it back. And When we did, we ended up with a minus sign in front, and then it changed the sign there, right? We did not have to change the sign inside the parentheses. This one on the outside is doing the job for us, okay? So one on the outside, and then we have to change this guy because he's not inside the parentheses, right? He's his own man. Okay, now we're ready to bring this to the next page and graph it. I'm excited. I always feel like a detective sorting through these clues. So here we go. And oh, I just want to write this. One more thing. After we got the square completed and everything that we wanted, then what we did is we toss the minus back to the right side. Again, you can think of it as dividing by -1 or multiplying, whichever fits better in your brain, but that's what we did right there. All right, and we had to do it to both sides. So there's me doing it to both sides. All right, now we're graphable. Now we have to remember all of that stuff, right? The whole axis of symmetry, vertex, which sign do you switch around? Oy, 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 oy. There, I'm fixing my light so it illuminates my page. Y equals minus x minus 1 squared, and this became plus 3. All right, so this tells us that this graph is going to open down. All right, this tells us that the axis of symmetry is at x equals +1. That's the one where we have to choose the other sign, plus or minus sign. This is the vertex and that is going to be at y equals +3. This is the nice guy who keeps his sign the same. All right, we need a graph. Okay, it opens down, check, we'll remember that. Axis of symmetry is at +1. So here, x equals +1. The axis of symmetry is always marked on the x-axis, right? And the vertex is always marked on the y. Okay, so the y value is +3. So we go to +3 on the y-axis and we put a nice dot there and we know this is gonna open down, okay? And then we have to find one more point, which technically we're finding 2 more points, right? Because we can use symmetry to find the other one. So here we go. We go 2 units to the right or 2 units to the left, whichever number we liked better. So our choices are, in this example, 3 or -1, right? 1, 2, 1, 2. I'm gonna choose 3. So now we plug that in here and we say y equals minus 3 minus 1 squared plus 3. And we have to solve that. 3 minus 1 is 2. 2 squared is 4. And then there's a negative in front of it. So it's -4 plus 3. And that means y equals -1. So our point that I used x, let me say that, x can equal 3 or -1. Our point is 3, -1. That's the one more point that we're gonna graph. So 1, 2, 3, -1, so it goes down. And then actually we can use that other number, that's the other x value, -1. We know that if we would have used that, we would have gotten the same answer, right? So -1, -1. That's another way we can find that second point. Again, we could use symmetry because we see if you go 2 layers over, you go to -1. 2 layers over, you go to -1. So 2 different ways to think about that second point. And there's our parabola. Mine looks a little pointy. Remember, they're not pointy at their vertex, they're rounded. So I'm just going to improve that a little bit. All right, this is our vertex here. The point of our vertex is 1, 3. We can calculate that, right? Our axis of symmetry is at x equals +1. And then our other points are right here. 1 more point. This is our solution. We did it right. Yay! Beautiful. Okay, one more. Because I don't know about you, but I'm having so much fun. I love these. I know it's a lot, and I know it's a lot of confusing stuff. There's kind of 3 layers, right? There's the whole completing the square thing, then there's the graphing part of it, and then there's the 1 more point, which usually, like at that point, students' minds are like, okay, I'm officially out of my mind here. We're gonna practice dealing with that minus sign again. Okay, so what I'm gonna do first is I'm gonna factor out all the minuses. I'm gonna factor the minus out. These minuses are great, but this is the one that really annoys us. This is the one that we're just like, no, 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 deal breaker. So then if we pull the minus sign from everybody, it's x squared plus 6x plus 8. Beautiful. This time I will multiply by -1. Last time I divided. Same. These cancel. And now the minus is over here. And we have x squared plus 6x plus 8. Last time I kicked it to the curb in the same step. This time I'm slowing down a little bit. All right, so now the minus sign is over here where it won't bother us. We're going to have to flip it back at the end, but for now we can just happily complete the scare. Yeah, kind of. X squared plus 6x, empty space, and we kick 8 to the curb. Magic number is, I'll write the formula again, b over 2 squared with an arrow inside the parentheses. Our b number is 6. This is 3. So our number is 9. Our magic number is 9. So we add 9 here and we subtract 9 there. Okay, this minus sign is just minding his own business. He's not bothering us at all. So now we're ready to write this as a perfect square. Minus y equals, the number inside the parentheses is what we want here. And this will be what? -1. Let's check our perfect square, make sure it works right. 3 times 3 is 9, 3 plus 3 is 6. Beautiful. If you calculate your magic number right, this will always work. And if you take the right number over, right? Okay, now we're ready to bring that minus sign back. So what I'm gonna do is I'm gonna wrap this whole right side in a giant set of mega parentheses, and then I'm gonna multiply each side by -1. I'm kind of out of space here. All right, this goes positive, so now we're back to just a good old y. This minus sign is going to sit out front of this, but we also have to apply it, right? It's kind of like a distribution, right? It is a distribution. This becomes a +1. So multiplying or dividing by -1, putting that minus sign back, like we did here, that's tricky. Be careful. Just watch yourself. That's a fabulous place for mistakes to crop up. So now we know opens down. The axis is at x equals -3, and the vertex is at y equals +1. All right, picture time. Our x, oh, it's way over here. Let me put in more markers so that I have a little more room to work. 1, 2, 3, it's right there. Well, it shouldn't technically be a dot, sorry. My brain's going sideways. The axis of symmetry does not require a dot. The axis of symmetry just requires these dotted lines. Our vertex is at +1. Our scale is going to be a little out of whack. So this is our vertex. This is just a dot that doesn't belong there. We know it's going to go down. We now calculate one more point. We can choose x values that are 2 units to the right or the left. If we go this way, it's -1. If we go this way, it's -5, right? We're just counting 2 to the right or left from our axis. I'm going to choose the -1. So then we plug in here, y equals -1 plus 3 squared plus 1. Okay, -1 plus 3 is 2. 2 squared is 4. So that's -4 plus 1. And that equals -3. So our point that we calculated is -1 minus 3. And if we want, because we're actually calculating 2 more points, that's my asterisk to say it's not really 1, it's actually 2. We can use -5 minus 3. We know that if we used -5 for our x value and plugged it in here, we get the very same thing. And you can check it really quickly, because just imagine this is a -5. -5 plus 3 would be -2 instead of +2, but once we square it, it would be 4, and then it would be -4, blah, blah, blah. So if you don't believe that, you can just quickly, mentally plug in the other number and see, oh yeah, it would turn out the same. So that gives us our quote-unquote 1 more point that's actually 2 more points, -1, -3, and -5, -3. And here is my cute little parabola. It's a little out of scale because I squished extra points in there and these are still kind of spread out, but it's okay. There it is. The name of that parabola is y equals minus quantity x plus 3 squared plus 1. This is the axis at x equals -3, and this is the vertex at y equals +1. Yay! That's a lot. If your brain feels exhausted, then you know that you are paying attention. See what you can do with that, and just know we're planting seeds, and next year you'll come back to it, and I'll tell you what, every student I've ever had comes back next year and goes, oh, okay, now it actually makes a lot of sense. So just hang on for this year and you'll be fine. All right, end of week 26. Yay, thank you, goodbye.